Hello everyone, and this is continuation of our last lecture on vectors where we discuss bit difference between scalars and vectors, what exactly a vector is, what is a unit vector, and how can we represent a vector, and also addition of two vectors, right? So today let's continue the same topic in same direction and discuss more topics here, right? So we discuss addition of two vectors, right? Addition of two vectors. Let me start from here. Addition of two vectors. So let's say there are two vectors, A vector, B vector, right? A vector has a magnitude of A, B vector has a magnitude of B, and this is C vector is my resultant vector which has magnitude of C, right? And theta is between the angle between A vector and B vector. So we need to find what is the resultant vector and what is the angle at which it is inclined, right? To one of the vectors, right? So we calculated that the magnitude of resultant vector will be given by what? A square plus B square plus 2AB cos theta, right? And angle we calculated that it will be given by what? Tan inverse B sine theta by A plus B cos theta, right? Clear? Okay. With this, now let's talk about subtraction of two vectors, right? When we talk about addition, next is what follow-up thing is subtraction, right? So subtraction of two vectors. So subtraction of two vectors or difference between two vectors, right, is same as that. So let's say we have to calculate now A vector minus B vector, right? A vector minus B vector. Okay. Let's understand this with a diagram, right? So let's say this is A vector, this is B vector. Okay. So resultant will lie somewhere in between them, and this is the resultant vector, right? This is C vector, which is the resultant vector. Now we need to calculate subtraction of two vectors. So can I write subtraction as in terms of addition? Isn't it like this? A vector plus minus B vector, right? Clear? So now I have converted this subtraction to kind of addition, right? Okay. So now this is A, this is B. Minus B vector will come anti-parallel to this B vector, right? So this is my minus B vector, right? So this is my A vector, this is my minus B vector. My resultant, let's say resultant somewhere it will be here. Let's say this is C dash vector, right? So let's say this is C dash vector. So this is my new resultant vector now, right? Okay, sure. So let's solve some problem on this and then we can understand more on what is subtraction and addition of two vectors, right? Let's solve some examples on sum of two vectors and also difference of two vectors to get more clarity, right? Okay. So the question is, two vectors of magnitude 5 units are angled 60 degree to each other. Find sum of vectors and then difference of vectors, right? Okay. Let's start with the first part. Okay. So first part A. So let's say there are two vectors, A vector and B vector, right? The angle between A vector and B vector is 60 degree, right? So we know the magnitude of A vector is what? 5 units. The magnitude of B vector is what? Again 5 units. Angle between A vector and B vector is nothing but 60 degree, right? We need to find the resultant vector. You know the resultant will come somewhere over here. Let's say C. C vector is the resultant vector. So we need to find the magnitude of resultant vector and also the angle it will make with the first vector, let's say alpha. So what is the magnitude of resultant vector? What is the angle, right? We need to find that. Okay. So simple, we know the triangle law, right? We can easily calculate. We know vectors and the angle. So it's very simple. C vector will be what? Under root mod A square plus mod B square plus 2 mod A vector B vector cos theta, right? Now I know all the values. Let's put all the values. So let's say This is 25, this is 25, this is 50 into cos 60, right? So this is what? This is again 25. So 3 times 25, it is nothing but 25 root 3 units. So magnitude of this resultant vector is what? 25 root 3 units. Let's find the angle. You can simply say both vectors are of equal magnitude. So it will obviously come from through the angle bisector only. Like it should make equal angle with both of them because both have same magnitude. We can say that by symmetry. But let's calculate, right? So we know the formula. Tan alpha, sorry, tan alpha is given by what? It is b sine theta, means it is b sine theta by a plus b cos theta. Clear? So I'm finding this alpha with respect to a, right? With respect to b, I can calculate by doing 60 minus alpha, right? So this magnitude of b vector is what? 5. Sine theta is what? Sine 60. A is again 5. This is again 5 cos 60, right? So this is nothing but 5 into root 3 by 2 by 5 plus 5 by 2, right? So if you calculate, this is what? 5 root 3 by 15. So this is 1 by root 3. So tan alpha is 1 by root 3. So alpha is what? 30 degree or pi by 6 radians. So this alpha is nothing but 30 degree, right? So you can see that now this vector is equally inclined with a and b, 30 and 30. So this alpha we found as 30 degree, right? Now let's move to the next part of problem, which basically says the difference of two vectors, right? So we have the given same values. We need to find the difference of two vectors, right? Okay. So let's change this to b part. And how my diagram will change now? The diagram will change like this. Now what I need to find is, we need to find a vector minus b vector, right? Let's not bother about minus. Let's make it plus, right? We know the formula for plus. So it is plus minus b vector, right? Let's call this minus b vector as something. Let's say this is called k vector. Anything. Just to remove this confusion of minus from head, right? So first let's draw a diagram. So minus b vector will come somewhere over here. So this is my minus b vector, right? This is my minus b vector, and resultant will come somewhere over here. And let's say this time resultant is d vector. Okay, clear? Okay. So now what I know, this minus b vector I have assumed is a name as k vector, right? Just for simplicity. So what I know now, I know the magnitude of a vector, which is again same as 5, right? Magnitude of k vector is also what? Which is magnitude of minus b vector, which is what? Again 5. Angle between a vector and k vector, now it is not 60, it is what? It is 120, right? So the angle between a vector and minus b vector or k vector is 120, right? Now we have the same formula because we are doing plus only, right? So let's do that. Let's forget that this was a question where we were doing the difference. We were calculating addition of two vectors which are having magnitude 5 units and which are angled 120 degree now, right? Okay. So now resultant is, this time we have, so d is the resultant vector, right? So let's say d is the resultant vector. We need to find a vector plus k vector. K vector is nothing but minus of b vector. Okay. So d magnitude will be what? Under root a magnitude square plus k magnitude square plus 2a vector k vector cos of angle between them, cos of 120 this time. Clear? Okay. So again, this is what? 5 square is 25, c square is 25, sorry 25. This is again 2 into 5 into 5, cos 120 is what? Minus 1 by 2. Clear? So what is the magnitude now? Can you calculate? This is root 25, right? So it is 5 units, right? This is 5 units. The magnitude is 5 units. So the magnitude of resultant vector here is 5 units, right? What about the angle? Again, same way, we can find the angle with respect to a. Let's say this angle. Let's say this is alpha 1. So again we can say that these are of same magnitude, so alpha 1 will be 60 degree, right? So by same way, same formula, you can calculate the angle as well, right? So when we calculated the sum of vectors, we noticed that what expression we got under root 25 plus 25 plus 2 into 5 into 5 cos 60, which was 1 by 2, right? This was the expression of plus. Here we have cos 120, right? Since we are doing for a negative, we are 180 degree shifted by the angle, right? Okay. So this we calculated the value. This was something like, what was the value we calculated here? This was 5 root 3 units, right? I think we mismatched it when we calculated, so it will be 5 root 3 if you calculate it properly, right? Okay. Let's move to the next topic. So next topic is resolution of two vectors, right? Resolution of two vectors. Resolution of two vectors. So this is a very important topic for concepts mechanics and with forces, and you see forces coming in different direction. You need to actually resolve those forces in different direction to get their components, their contribution in different directions, right? Okay. So let's say this is a Cartesian plane, right? XY axis. You know the unit vector along x-axis is what? I cap, and y-axis is j cap, right? Let's say we have a vector here. We have a vector. Okay. Let's say this vector is r vector, right? This vector is r vector. It has a magnitude, let's say r, and it is making some angle like alpha with x-axis, right? So now this vector will have a component in x direction as well. This vector will have a component in y direction as well, right? Okay. How? Let's say this is O origin, right? So I just said that this vector will have component in both the direction, right? So orthogonally it will have components in x direction as well and y direction as well. Let's say how. So let's say the component along x direction is OA and component along x direction is OB. So OA vector is the component along x direction, OB vector is the component along y direction. And we know, according to triangle law, that if I take resultant, if I add OA and OB, I'll get R vector, right? So addition of these two vectors, these two are orthogonal to each other in x and y directions. So addition of these two vectors are giving me R vector, right? So I can say that R vector gets some component from x axis and some component from y axis, right? Clear? Okay. Now what are these components, right? What are these components and how would we represent them? So let's talk about magnitude, then we will talk about direction, right? Okay. So let me draw a perpendicular over here, right? Perpendicular. So this has a magnitude OA vector, right? And this has a magnitude OB vector since it is parallel to y-axis, right? So if I take sine alpha is what? OB vector by R. R is the magnitude of R vector, right? So OB vector magnitude is what? R sine alpha, right? Clear? Similarly, you can find for OA also. OA vector magnitude will be what? R cos alpha, right? Clear? So now I have calculated the magnitude. Now can I find the vectors in x and y direction, OA and OB? So it's very simple. I said that to represent a vector, you just need a unit vector. So OA vector will be what? R cos alpha, I cap. OB will be what? R sin alpha, j cap. And if I add these two, R cos alpha I cap plus R sin alpha j cap, I'll get R vector, right? So this R cos alpha I cap is the component along x direction, component along x direction, and this R sin alpha j cap, this is the component along y direction, along y direction. So we can say that any vector can be written as a sum of two orthogonal components, right? And that is what we call resolution of two vectors, right? And you see, this is a r vector, right? So this was angled alpha with respect to x-axis. So along alpha, it's a very general rule. Along alpha, if you take along alpha, the component is always cos, which is OA, it is r cos alpha. And the other, obviously, other orthogonal component will be sine, right? Clear? So let's understand this by one more example. Not example, but yeah, how do we use this resolution of two vectors, right? Okay. Right. Okay. Let's say this is a surface, right? And there is a plank kept on this surface, right? Plank kept on this surface. And I am exerting a force in this direction to this clamp, right? Okay. This force will produce motion. Force has capability to produce acceleration and hence motion, right? So this force will produce motion in both the direction, right? In this direction as well and in this direction as well. Maybe the object will move in this direction, but to calculate displacement, you need to find the displacement along x also. You need to find displacement along y also. How much it has displaced horizontally, how much it has displaced vertically, right? So if you need to find anything in along x direction, be it force acting on it, be it acceleration, be it distance it is traveling, you need to know the force which is actually acting in x direction, right? This force is the net force, right? This f vector is the net force. But if I resolve it, so if I resolve it, it will have a component along x direction as well. And this component is responsible to produce acceleration in the x direction, right? Y component will not do that. Y component will do it for y direction, right? Clear? So if this is theta, I just explained this will be f cos theta and this will be f sin theta. So if I know the mass of this body, I can say acceleration along x direction will be what? F cos theta by m. And acceleration will be in y direction will be what? F sin theta by m, right? And net acceleration, you can obviously say this is what? Under root x square plus ay square, right? Clear? Because both are orthogonal to each other, both are acceleration, right? So cos 90 component will go off. Same with vector law, what we just studied, right? Okay, right. So we studied addition of two vectors. We studied subtraction of two vectors. So you know what comes after addition and subtraction? We have multiplication of two vectors. Multiplication of two vectors. Basically product of two vectors, right? So there are two types of product in vectors, right? There are two types of product, right? So there are two types of multiplication of product. One product is called scalar product. Another type of product is called vector product. Right? One type of product is called scalar product. Other type of product is called vector product. Scalar product is also called as dot product. Most common name is dot product. And vector product is also called as cross product, which is more common name, right? Okay. So as the name suggests, right? As the name suggests, the output of this product will be a scalar value, right? So we are multiplying two vectors using dot product and we will be getting a scalar value, which is a numerical value. For cross product or a vector product, the resultant will be a vector value. So the resultant will have a magnitude as well as it will have a direction component as well, right? Okay. So let's talk one by one. Dot product or scalar product. So let's say there are two vectors, A vector and B vector, right? So, and it has angle theta between A and B vector, right? So by definition, dot product of A and B, A dot B, it will be given by magnitude of A vector, magnitude of B vector, cos of angle between them. right? So dot product of A vector and B vector will be given by product multiplication of magnitude of A vector, magnitude of B vector, and cos of angle between them, right? You see that this is a scalar result. There is no direction, there is no unit vector, there is no vector symbol, anything in the RHS side. This is a scalar result, right? Okay. But what is the meaning of dot product? Let's say if I rearrange this, so so this basically means A vector cos theta multiplied by B vector. Can I write it like this? Right? This is what A vector cos theta into B vector. Now, if I resolve, I just talk about resolution of two vectors. If I resolve A vector along this direction, the resolution will be something like A vector cos theta, and along horizontal it will be A vector sin theta, right? So along this direction, it will be A vector cos theta and A vector sin theta in the orthogonal to it, right? So A vector cos theta is the component of A vector along B direction, right? A vector, just follow what I'm telling. A vector cos theta is the component of A vector along B direction, right? And that's what is the significance of dot product. So component of one vector along other vector multiply by the magnitude of vector is dot product, right? Okay. So if I need to find the component of A vector along B vector, which is A vector cos theta, I can find it like this: A vector dot B vector by B vector magnitude, right? Clear? Let's understand by one example, right? Let's understand by one example. Again, let's say there is a plank, right? There is a plank. Clear? Okay. So we are applying force on this clamp, right? And let's say it is moving in this direction, right? It gets, because of this force, it gets motion in this direction, right? Let's say this is displacement x, it has traveled right along this direction, and force is in this direction, and I need to find the work, right, done by this force. What is definition of work? Work is, work is the product of force into displacement. You would have studied in your junior classes. But actually, when we talk about work, we talk about displacement in the direction of force, right? So work is said to be done only if there is a displacement in the direction of force, right? If force and displacement are perpendicular to each other, there won't be any work, right? So only and only if there is a displacement in the direction of force, work is said to be done, right? So you see, displacement is in this direction, horizontal direction. Force is acting with at some angle, right? Let's say this angle is theta. So along this displacement, the force will be what? F cos theta, right? So this F cos theta is responsible to displace this body by x in horizontal direction and not F. So work will be what? F x cos theta. And again, I can write it like F dot x. So work is what? Work is the dot product of force and displacement. It's not normal scalar product of force and displacement. So when we talk about work, we talk about force acting and displacement produced in the direction of force, right? So this is what work is. Okay. So we just calculated the component of force along the direction of displacement F cos theta, which is responsible to create this displacement. Now you can relate it to dot product, right? So dot product is what? A dot B is nothing but magnitude of A, magnitude of B, and cos of angle between them. A cos theta is nothing but the component of A along the direction of B, and B vector is the B vector which is input given to us, right? Now you understood what is dot product, right? Okay. Now let's do some exercise on dot products, right? Let's do some exercise on dot products. Before doing that, I just explained A dot B is what? A vector, B vector, cos theta, right? So if theta is equal to 90 degree, if theta equal to 90 degree, what is the dot product of A dot B? A dot B will become 0. Clear? A dot B will become 0. Very clear? Okay. So if I just said that if force and displacement are orthogonal to each other, they are 90 degree they are at 90 degree to each other, there is no work done. So work will become 0, right? If theta is 90 degree. So if theta equal to 0 degree, what happens? Cos 0 is 1. So dot product will be same as the product of magnitude, right? And this is the maximum possible value of this dot product because cos theta max value is 1, right? Okay, right. Okay, let's talk about unit vectors now. Unit vectors. So for, let's say we have Cartesian plane, right? Let's say we have Cartesian plane. X, Y, and Z, right? So unit vector along x direction will be what? Unit vector along x direction is I cap. Along y it is j cap. Along z it is k cap, right? So let's do a cross combination and find dot products between these unit vectors. So I cap dot I cap will be what? I just said A dot B is what? Mod of A, mod of B, and cos angle, because they are same, so cos 0. Mod of unit vector is 1, 1, cos 0 is 1, so 1, right? And which is same as j dot j and which is same as k dot k, right? So dot product of two same unity vectors are 1, right? Let's do the cross combinations now. What about I cap dot j cap? Now you can simply say, I just said, in the dot product of any orthogonal vectors are 0. So these two are actually orthogonal to each other. These two are having 90 degree to each other. So dot product will be obviously, since cos 90 will come, so this will be 0. So any cross combinations you take, different cross combination, not the same, like I cap dot j cap or j cap dot I cap or I cap dot k cap or k cap dot I cap, anything you take, the dot product will be 0. Only the condition is these two vectors should not be same. If they are same, the dot product is 1. These are the case of unit vectors, right? Okay. So let's solve one problem on dot product. Right. Let's solve one problem on dot product, right? So suppose a force 12 Newton acts on a particle in vertically upward direction and particle is displaced 2 Newton, sorry, 2 Newton, it won't be here, it should be 2 meters. 2 meters in vertically downward direction. Find the work done, right? Let's understand the question, right? Let's say there is a particle, right? Force acting is vertically upwards. Force is 12 Newton. It is acting vertically upwards, right? Let's consider this as coordinate system xy. So force is acting in positive y-axis, right? But displacement is in vertically downwards. So it is displacement is in vertically downwards, right? So this is 2 meter and it is in this direction, right? I need to find what is work done, right? We just talked the work done is nothing but cross dot product of force into displacement, right? If I write force in vector form, can I write it like that? F vector is equal to 12 j cap. And what about displacement? Displacement vector is nothing but 2 minus j cap, since it is in the negative y. Can I calculate work now? Work is what? 12 j cap dot 2 minus j cap or minus 2 j cap. So constant I'll take out, minus 24 j cap dot j cap. We just talked j cap dot j cap is 1. So work is what? Work is a scalar. The resultant of two dot product is always scalar quantity. So work is minus 24 joule. Work is negative here. So work is negative because the displacement is opposite to the direction of force, right? So it is happening opposite, right? Whatever we are trying to do, it is happening opposite of that, which happens generally in life also, right? So it's like that, okay? Right, okay. So let's solve one more problem on dot product, right? Let's say a vector is given by 1 I cap plus root 3 j cap, right? Let's say a vector. And let's say b vector is given by root 3 I cap plus 1 j cap. 1 j cap means j cap. Same, right? Now we need to find find first is dot product of A and B, and second is angle between A vector and B vector, right? A vector and B vector, right? Clear? So to calculate dot product, let's start with first part of the problem. So to calculate dot product, what I need? A dot B is nothing but mod of A vector, mod of B vector, cos of angle between them, right? Okay. So this is how we calculate dot product of two vectors, right? In this particular question, I am given with the what is the component of both the vectors, right, along x and y axis, right? So let's try calculating dot product like that without using, because we don't know what is theta. We actually need to find theta in the next question, right? So if I put 1 I cap plus root 3 j cap dot of root 3 I cap plus j cap, right? Now we know that I cap dot I cap is 1, but I cap dot j cap is 0, right? So if I try to take it like that, like you know the how do we do normal multiplication? So take 1 I cap. This is dotted with root 3 I cap plus j cap, right? And take root 3 j cap. This is dotted with root 3 I cap plus j cap. So only I cap dot I cap and j cap dot j cap will survive. I cap dot j cap or j cap dot I cap, they will vanish. You know the dot product of two orthogonal vectors are 0. Okay. So this will be what? 1 root 3, and here root 3 and 1. So root 3 again. So this is 2 root 3. So dot product of A dot B is 2 root 3, right? Now I need to find angle between A and B, right? Which means theta I need to find, right? So can I use the same formula to find theta now? I know the dot product. Dot product of A dot B is 2 root 3. Let's solve the second part of it. Right. So cos theta is nothing but A dot B by magnitude of A, magnitude of B. I know A dot B is what? 2 root 3, right? Magnitude of A you can easily calculate. You can tell me magnitude of A is what? Under root 1 square plus root 3 square, which is 4, which is basically 2, not 4, which is same as magnitude of B. So again 2 into 2, right? So this is nothing but root 3 by 2. So theta will be what? Cos theta is root 3 by 2, theta is 30 degree. So angle between both the vectors is 30 degree, right? And we calculated the dot product as well, right? Okay. So we just understood problems on dot product. Let's talk about cumulative law, right? Whether A dot B and B dot A, whether they'll be same or not, right? Right. So let's understand whether these dot product follow the commutative law or not. So A dot B will have one magnitude and B dot A will have one magnitude, right? So whether both will be same or not. Let's say there are two vectors, A and B, right? So dot product will be what? This is mod of A, mod of B, and cos of angle between A and B, right? Okay. So let's say angle is positive in anti-clockwise, right? And let's say angle is positive in anti-clockwise and negative in clockwise. So we need to specify direction for angle. And from A to B, let's say this is negative angle, right? So even if it is minus theta, this will be cos minus theta is cos theta, right? So it is that. And B vector dot A vector is what? Again, B vector, A vector, cos theta, angle in this direction. Again, cos theta is as same as previous one. So you know the cos minus theta is again cos theta, and hence this dot product will follow this commutative law, and A dot B will be always equal to B dot A, right? Right. And in last problem we saw that it also follows the distributive law, right? Which means A dot B plus C will be what? A dot B plus B dot C, right? Clear? Okay. Let's talk about cross product. Cross product. What exactly is cross product, right? Cross product is also called as vector product. which basically means the result of a cross product, the resultant of a cross product will be a vector quantity which will have magnitude as well as direction, right? Okay. So now A vector cross B vector is given by A vector, B vector, sine theta, n cap. A cross B is given by A vector mod, B vector magnitude, sine of angle between them, and n cap. Let's talk about what are these quantities. So let's say this is A vector, this is B vector, this is angle theta, right? So when we talked about dot product, we have AB cos theta. Here we have AB sine theta, right? So this basically means if I rearrange it, any of it, this is what? This is, can I write it like this? Can I write it like this? A vector into B sine theta and n cap. So this is component of B. So the component of B parallel to A will be what? B cos theta. And perpendicular to B, A will be what? B sine theta. So in dot product, we talked about the component of B which is overlapping with A, right? But here we are multiplying the component of B which is perpendicular to A, and the result is a vector quantity. So we have n cap also. So what is the direction of this n cap? N cap is a unity vector, and this has a direction cross of A cross B, right? This is in a direction cross of A cross B. So let's see how can we find direction of n cap, right? So direction of n cap we can calculate like, if we are finding A cross B, we can put our hands along A direction and then we curl it towards B. This is the direction of unity vector, right? Which is out of the board, right? So this n cap vector is perpendicular to A vector as well as B vector, right? Okay, clear? So let's understand by an example, right? Let's understand by a simple example. Let's say we have a coordinate system x, y, z. This is I cap, this is j cap, this is k cap. So what is I cross j, right? What is I cross j? This is what? Mod of I, mod of j, sine of angle is sine 90, and n cap, right? So mod of I is 1, mod of j is 1, sine 90 is 1, n cap. So what is the direction of n cap here? We take our hands along this I, we call it toward y. So this thumb gives the direction of n cap, which is pointing towards the positive z axis, which is k cap. So I cross j is nothing but k cap, right? Clear? Right? Okay. So similar to that, we can find other unit vector cross combinations as well. Let's find a bit more. I cap, j cap, k cap. So here if you take two same vectors, you know sine 0 is 0. So this will make it a 0 vector, right? This is a 0 vector, right? But if you take two orthogonal here, right? I cross j, you see this is I cap, j cap, cos 90, and n cap. You know this is k cap, right? I just explained you why it is a k cap. If you take j cross I, opposite of this, right? So this will be what? Mod of j, mod of I, cos 90, and instead of n cap there will be minus n cap, right? And then this will be minus k cap. Why it is minus k cap? Now you take hands along j, curl it towards y. This is going inside the board now. So this is towards minus z axis, right? Okay. So this is minus k cap. Hence you see the I cap cross j cap is negative of j cap cross I cap. This is not commutative, right? Which was the case in case of dot product, right? So cross product is not commutative, right? So in our next lecture, we will talk how do we find the cross product of two vectors and what is the application of dot and cross product, and we will talk a bit on the differentiation as well, which is also part of mathematics. Thanks.